Hello everyone. So today I'll be discussing how to calculate rate ratios in Microsoft Excel. These are the learning objectives. Explain the purpose of a contingency table, review of the rate ratio equation, and then we're going to calculate rate ratios in Microsoft Excel using three small data sets or 2 by 2 tables. So this is the contingency table, and over here you can see the disease status in terms of it is viewed, actually read looking vertically, and then you have the exposed status, so it's horizontal. And then of course you have the totals. For contingency tables, you can calculate different types of measures of associations, such as odds ratios, risk ratios, and rate ratios. If you'd like to learn how to create contingency tables, please look for the prior mini lecture in which I discussed the purpose of a contingency table and how to create it. Next, this is the rate ratio equation, also known as the incidence density ratio. And as you can see here, we have two different parts of the equation. So the numerator, we have A divided by person time. A represents an individual who is diseased and also is exposed to some type of risk factor. And then we also have person time. Person time data can be calculated in months, years, or days. And then for the denominator of the equation, you have C. C represents a person who is diseased but not exposed. And then, of course, they have their own person time data, which is measured in days, months, or years. So this is the first data set or contingency table, and it represents the total smoking cigarettes and the risk of developing lung cancer. As you can see, you have the smoking status. So individuals who smoke cigarettes and do not smoke cigarettes. And then of course you have your lung cancer cases and then the person years. The person the person time in this case is calculated in person years. Next, we're going to go over to the Microsoft Excel. And in Microsoft Excel, we have our first 2 by 2 table or data set. And here you can see that I did the calculations for you all in advance, but I'm going to clean this up for you so we can do this together as a cohort. So here you have the smoking status, and you have individuals who smoke cigarettes and who do not smoke cigarettes, and you have your lung cancer cases. So that's 400 for individuals who smoke cigarettes and 1100 for individuals who do not smoke cigarettes. Then you have their person time data calculated in person years. So to calculate the risk of developing lung cancer among individuals who smoke cigarettes, we look at, of course, the column, and this here is column C, and then we look at to where this is located. So it's located in number 4, which is the 4th row. So this position is C4. So we write down our nice equal sign. So C4 divided by D4. And that gives us 0.1. Then the next part is we want to calculate the risk of developing lung cancer among individuals who do not smoke cigarettes. So that is C5 divided by D5. So you have a C5 divided by D5, and that's the risk of developing lung cancer among individuals who do not smoke cigarettes. Now, if we want to calculate the rate ratio, what we do is we have this first part, it's F4, and this is S5. So what we do is we have equal F4 divided by F5, and that's 1.54. Now, let's go back to our next data set, or 2 by 2 table. So here what we did was we stratified individuals who smoke cigarettes by their age group. Stratification will be discussed in a prior mini lecture. So over here we have our smoking status, individuals who smoke cigarettes and who do not, and our lung cancer cases, and of course our person time data, which was measured or calculated in person years. So we go back to our Microsoft Excel, and they have the question here. It says calculate the rate ratio among women in less than age 45. So of course we have this 100, 600, and then the person years. So we need to do this nice, interesting calculation. So here, of course, among individuals who are exposed, they're located in C 12 and D12. So we have equals C12 divided by D12, and that gives us 0.1. And then, of course, here we have the rate ratios among individuals who do not smoke cigarettes. So that's C13 divided by D13. So that, of course, is equals C13 divided by D13, and that gives us 0.06. And if we want to calculate the rate ratio among women less than 45, what we do is we have these two interesting spots. And here we can put equals C12. Sorry about that. This is F12, and then this is F13. So that gives us F12 divided by F13, and that gives us 1.66. Now, to our last data set here, we have is women older than 45, and you can see their smoking status, of course, women who smoke cigarettes and who did not, and then the lung cancer cases that appeared for both the exposed and non-exposed group, and then you have their person years. So this, of course, was created in Microsoft Excel, and we'll do our nice calculations. So, of course, we have our rate ratio among women who smoke cigarettes and became lung cancer patients, and we can signify this numbers, of course, with red color font once again. And here we have C19 divided by C30, so that's equals C19 divided by divided by D19. Okay, so that's 0.1 again. These are interesting, easy numbers to calculate with. And then here we have the relative risk of developing lung cancer cases among women greater than 45. So that, of course, will be located C20, and then we have D20 as well. So this is equal sign C20 divided by D20, and that gives us 0.071. And if you want to calculate the rate ratio among 45 women age 45, this is located in F19, F20. So we have our equal sign equals F19 divided by F20, and that is their rate ratio. So this is interesting calculations that you can do in Microsoft Excel or either by hand. But if you want to get more data savvy, you should start with Microsoft Excel before venturing off to statistical packages such as SAS, SPSS, Theta, and R. Thank you all for listening to this mini lecture, and stay tuned for more videos from the Public Health Academy.